All right, hello everyone, and welcome to our populations, paramecium data, and summary notes video. So we're going to be doing this page, and this is mostly you're going to be doing it on your own. I'm just going to kind of walk you through the process, and then we will do this second page together. So first thing that you're going to need is to find the data for this. So you're going to go into Canvas, and in week 5, you can get it two ways. You can get it through the online data, Paramecium data and summary notes video, or there is also a link that will take you to a PDF of that data. Either way, you decide, that will get you the data that you need and the information that we are going to be using for this video. I'm going to go ahead and open it just so I can see it a little bit better. And maybe not. Let's try again. Okay, well, either way, maybe it'll open in a second. So what you're going to do is you are going to use this Paramecium data, and you are, oh, there it is. You're going to use this Paramecium data to fill out this table. So essentially what you're going to do is count how many Paramecium, we're going to call this PC. So unless you want to try to pronounce that, we're going to call it PC. And you're going to notice that there is some days. Oh, looks like we're missing some data in this. So it's complete in here. So that's super strange, but okay. So what you're going to do is you're going to count, and I'm going to kind of change how mine looks a little bit. So times 0, we'll go ahead and say that this is day 0. Time 1 is day 2. Time 2 would be day 4. Time 3 would be day 6. Time 4 would be day 8. Time 5 would be day 10. Time 6 would be day 12. Time 7 would be day 14. And you will notice that this goes to 16. So we're going to add a column for day 16. And what you're going to do is count how many there are in each of these different days. So for the PC day 0, there's only 1. Then for day 2, or time 1, there is 4. And you're going to do that for each of the days. You're going to do the same thing then for PA, which is over here. And again, it looks like there's 1 to start, and then there is 4, and so on and so forth. So you'll count how many there are in each of these grown alone and put that in your table right here. And then you're going to have to probably make this bigger and zoom in on the data so that you can count how many there are of each type in the mixed culture. So it looks like in day 1, there is 1 of PA, and there is 1 of PC. So like I said, you're going to have to zoom in and kind of get a good count of these things so that your data will be good, but you're going to fill out this table. When you're done with that, you're going to go ahead and graph your data. So that's going to look a little strange. And I'm going to kind of set up the axes for you, but you're going to decide how you're going to label or how you're going to space it out. So the y-axis in this case is population number, and the x-axis will be time. So however you want to create a scale, you can do that. Now remember that our time is 0 to 8, not 0 to 16. So you could put 0 to 8. You could put 1 just 0, 4, or 0, 8, and 16, which is how I'm going to set mine up. But you can do it however, and you should have a pretty nice curvy line. These boxes down here are for you to sketch. So the first box will be what we call time initial, and that will represent time 0 or day 0. I'll go ahead and write day 0 just so that it's clear. Then we're going to do time half. So time half would represent halfway through our data collection, which would be time 4 or day 8. And then you're going to do another graph for TF or time final, and that would be our time equals 8 or day 16. So you'll sketch what you see in each of those days for just one of the cultures. It doesn't matter which one you pick, just choose one of these two to graph and sketch down below. Then you're going to do the same thing essentially for the mixed culture, except you will need to be doing both. So I'm going to go ahead and just put that purple equals the C1 and orange will equal the A culture. And you're going to do the same thing. So you're going to have population number or how many there are, and then you're going to have some time scale, whatever you choose to do. Again, you're going to sketch what you see there, and you'll be sketching for both of these. So how many were there at day 0 of each one of these cultures? And you will do that for, again, time half and time final. And you will have a nice looking graph here. So I'll go ahead and just show you what I'm expecting for the initial and kind of where to start the graph. So I'm going to go ahead and do it for the PC1. And at the initial time, there was just one paramecium. So however I label this, I'm going to start off of 1 a little bit. And you will have a squiggly line with all your data. At the mixed culture point, there was one of each of these at day 0. So I'm going to put 1 of my PC and 1 of my PA. And again, they'll both start, I guess, right at the same spot. So that might be a little bit tricky to draw, but you'll have 2 lines on this graph. So go ahead and pause the video and complete that. And we're going to start the next thing. So down here, I'm going to go ahead and just roughly sketch what I saw for the PA culture. So at time initial, time half, and time final, there was just 1 for time initial. There was 2, 4, 6, 7 at the halfway point. And whatever one you did on this side, do the other one here. So graph the opposite one. And then for time final, there was 2, 4, 6, 8. And we will go ahead and create a sketch for this graph. Again, you should have some numbers down here. I'm just going to do it like this because I'm roughly sketching it. So we're going to start off of the bottom of the graph because we had 1 at time equals 0. And this started off really good and then kind of started to level out. So this is time half and time final. So let's go ahead and talk about our findings. The general trend of population number increases initially until it levels off at the end. So populations tend to have a cap that appears to be species specific. So every population has a point where they might start to level off, like we saw here. The higher population that had the larger cap capacity was the PA1. Now, the y-intercept gives us valuable information on the initial population size. So before we even started the time, we knew that there was one of each of our 2 different Paramecium cultures present before time even started. The slope, if we were to try to take the slope of this, would show us the rate of population change. And this is mostly focused on growth. So we would focus most on growth primarily. Now looking at the mixed culture, again, you're going to have to redo your graph, but I will go ahead and just do a quick sketch. Yours should be much more specific. And again, we're going to make a little key just so that we stay consistent. Okay, so at time initial, it looks like there was one of each of our 2 species. At time half, there was only 2 of our PCs, and there was 2, 4, 6 of our PAs. And at time final, there were no PCs, and it was all PAs. 2, 4, 6, 8. Okay, so now graphing this again, population number and our time on the x-axis. I'll go ahead and graph the PC first. So we started a little bit above 0. We started to grow and then began to level off. That would mark our T half point. For our PAs, we started at the same point as the other one because we had 1 of each. This one started off a little bit slower and then began to grow and started to level off. And these 2 points that I marked on here represent T half. So doing our mixed culture summary, it appears that there is some interaction between populations based on population number changes. So as this population began to grow, our other population started off a little slower. Then that population started to grow again, and our purple started to slowly die off. So PA didn't reach population cap until the PC died out. Population numbers are lower when grown in a mixed culture. And we could see that from the data that you graphed previously. It appears that these species and all species tend to compete for resources, and that can change how they survive. So that is the end of the note video. Let me go ahead and shut it off.